Okay, so in this section, we're going to talk about a new form of talking about angles. It's a different unit than our traditional degrees. If you remember that degrees comes from thinking about a circle as 360 degrees. And so if we turn halfway around a circle, that is 180 degrees. If we turn a quarter of a way around a circle, that's what defines a 90-degree angle. If we turn 1/360th of a circle, that is 1 single degree. Well, a radian is similar to that, but instead of it being 360 degrees representing one full circle, we say that one full circle is going to equal 2 pi. And that's an important thing to understand, and it's an important place to start, is recognizing that 360 degrees in degrees is equivalent to 2 pi. Right? They are the same idea. They represent the same thing. And if you can do that, that can help you go back and forth between radians and degrees, if you can remember that. Where does the 2 pi come from? Remember, 360 degrees came from because 360 is a nice number. It's easily divisible. There's some other reasons for it. But it was somewhat arbitrary. Same thing with 2 pi. It's somewhat arbitrary, except for the fact that 2 pi has a very specific representation, and that is the circumference of what we're going to refer to of a unit circle. A unit circle is simply a circle with radius 1. Right? The circumference of a circle uses the formula C equals 2 pi r. So if r equals 1, the circumference, the distance around, is considered 2 pi. So if you think about that, if we put it on a grid where we have a circle here, right, where our radius is 1, well, 90 degrees then is going to be just 1/4 of the circle. And so if you think about it, what would be the measure of 1/4 of a circle? Well, we know that in degrees it's 90 degrees, but in radians it turns out that it's just going to be 2 pi divided by 4, right? 1/4 of the circle, and 2 pi divided by 4 just equals pi over 2. And so as we begin to develop this in our understanding of radians, we start to recognize, oh, a 90-degree angle in radians is just pi over 2. And so you get pi over 2 here. And so that means 180 degrees is another pi over 2. Well, pi over 2 plus pi over 2 is just pi. Or you can think about 180 degrees as 1/2 of a circle. And 1/2 of 2 pi is just pi. 2 pi divided by 2 is pi. And so the next one down here, 270 degrees, is just going to be another pi over 2. It's just 3 pi over 2. And then finally, when we get back to 360 degrees, we get our 2 pi. And so remember what we talked about in chapter 12, where there is this nature of degrees around a circle, that 0 degrees is the same as 360 degrees, is the same as 720 degrees. Well, now, instead of adding 360 each time to get the same angle around a circle, we're going to be adding 2 pi. And so 0 degrees, 0 radians is the same as 2 pi radians, is going to be the same as 4 pi radians, is going to be the same as 6 pi radians, and so on and so forth. So what you're going to need to be able to do is convert these back and forth. And so some of them are very easy to do. So for example, for these, let's convert from degrees to radians. And so when we do that, we might have an angle like, let's say 210 degrees. So the question is, how do you want to go about doing this? There's different ways of doing it, and if you've got a way that seems to make sense for you, then that's a nice way to do it. People do it in different ways. One way to think about it, the way I like to think about it is do it like this, where you take 210 out of 360. That's what fraction of the circle 210 degrees is, right? Because we know in degrees, a circle is 360. And then multiply that times 2 pi. So I say, well, what fraction of a circle is the degree measure? Then take that and multiply it by our circle, which is 2 pi, and it now becomes radians. And so that just then is 210 divided by 30 is 7, 360 divided by 30 is 7. So that gives us 7 over 12 times 2 pi, which turns out to equal 7/6 pi. Note, when we come back up here to this, remember that 180 degrees is equal to pi. That's one of those things that you just need to get in your head, that 180 degrees equals pi radians. Well, 7/6 pi is a little bit bigger than 1 pi, right? It's 1 and 1/6 pi. And so, yeah, that makes sense, since 210 degrees is just a little bit bigger than 180 degrees. Your book does it a little bit different. And what it does is it takes this calculation and it says, well, another way you can think about it is, instead of doing 210 divided by 360 times 2 pi, you can think about it as 210 degrees times 2 pi over 360, or which is equivalent to, and so what your book says is, if you want to convert from degrees to radians, all you really have to do is multiply by pi over 180, right? Because that's ultimately what I did right here, right? As I multiplied by 2 pi and I divided by 360, and 2 pi over 360 simplifies to pi over 180. So you just take the degree measure, multiply it by pi over 180, and you have your radian measure. So let's do a couple more examples of that. You might have one that is like this, negative, let's say 225 degrees. So again, you can either do it like I do it, which is divide by 360 and then multiply by 2 pi, or you can just multiply by pi over 180. So you just take negative 225 times pi over 180. Notice 45 goes into both of those, and so that just turns out to be negative 5 pi over 4. When we're looking at our circle, there's two. We've already made a look at one important angle, and that is the 90-degree angle is pi over 2. And so we can build each 90 off of pi over 2 just by adding a pi over 2 each time. And so you can do the same thing with 45 degrees, right? 45 degrees. Well, 45 degrees is exactly, right? 45 over 360 is 1/8. 45 goes into 360 8 times. And so 45 over 360 is 1/8. So 45 degrees just turns out to be 2 pi over 8, which is the same as pi over 4. And so that's an important idea. When you start thinking about all these 45-degree angle ones, right? This is pi over 4. 2 45-degree angles is a 90, which is pi over 4 times 2, which is pi over 2. 135 degrees, right? Another 45 degrees. Well, that is 1, 2, 3 45 degrees. And so it's just 3 pi over 4. 225 degrees is the one that we just did right here, right? Except we have the negative there, but is going to be 5 45 degrees, 5 pi over 4. And you start to see that each of these 45 degrees is just the next blank pi over 4 odd number. Gives you, so 315 degrees is 7 pi over 4. 405 degrees is 9 pi over 4. 495 degrees is 11 pi over 4, and you keep adding pi over 4 each time. And then the same idea happens for 30 degrees. Right, 30 degrees is just going to be 30 over 360 times 2 pi, or you can just do 30 times pi over 180. Well, that simplifies to pi over 6, right? 60 over 360 pi. 60 over 360 is 1/6, and so you just get pi over 6. And so now we have the same idea in that each 30 degrees, it breaks it down into pi over 6, right? Now this time we have with 30, we get 30 degrees and 60 degrees, and so we get pi over 6. 2 pi over 6, which is just pi over 3. Pi over 3 is 60 degrees because it's building two of our 30-degree angles together. 3 pi over 6 is just pi over 2, which is, again, another way of showing the 90. And you can do the same thing we did with the 45, and you can build each one. So one thing to recognize, denominator of 4 tells you that you're working with 45-degree angles in some form. That's probably what your reference angle is going to be. Denominator of 6 or of 3 means that you're going to either have a pi over a 30-degree angle or a 60-degree angle. All right, and then the other thing you need to do is convert from a radian measure back to a degree measure. And so when you do that, and so you're going to do something like, let's say you have 5 pi over 6, and you want to convert this to a radian measure. Well, if you think about it this way, up here, we said that the way that you can go from radians, degrees to radians is to multiply the degrees, right? Our degree times pi over 180 equals our radians. Well, if we just solve this to find degrees, all we need to do is multiply radians times 180 over pi. And so if I've got 5/6 pi, or 5 pi over 6, and I want to convert it to a degree measure, I just multiply times 180 over pi, right? All I did here is just multiplied by the reciprocal of pi over 180. And so the pi's cancel. 6 goes into 180 30 times. So 5 pi over 6 turns out to be 150 degrees. If it's just a completely random angle, if it is, let's say, something like 2, and so this is 2 radians, not 2 degrees. Well, what is 2 radians as a degree measure? Well, you just do 2 times 180 over pi, and that gives you 360 over pi. That's the exact value of it. If it says round it to the nearest tenth, which is what I think your book does, then you just divide 360 by pi in your calculator, and that gives you 114.6 degrees. And so the 2 radians is equal to 114.6 degrees. That is a point that gets confusing for students because most of the time when we talk about radians, we include a pi as part of our answer because it's so nice and easy to do. But you don't have to. Your radians can just be a whole number too. And so when we convert that, you have to multiply by 180 over pi. The pi doesn't cancel out, so you end up with an irrational answer, something divided by pi as your answer. So that's how you convert from radians to degrees and degrees to radians. This is an important topic because this is how we're going to start graphing functions that include trigonomic functions in them. And radians makes graphing functions something that's very easy to do, whereas degrees makes it very difficult to do from a x-axis standpoint. So radians are very, very important. They're what you're going to use extensively in calculus, and so we need to know how to use radians really well.